Okay, let's make balls fall. So what to start with? Well, let's import turtle. Let's talk about the screen for the bit. Let's say the width of the screen I want to be about 300. I want to also make the depth of the screen a lot bigger than 300 because the object needs to fall further. 300 is about this length, so let's make this about 10,000 or 9,000. No, 10,000 is good enough. So now what we're going to do is we're going to do screen. Let's define it first, actually. So turtle dot screen. That will do. And then I need, let's set it up. So screen dot setup. In screen dot setup, you're literally just describing the initial structure. So width and width. I want it 300 by 300 at the beginning. I don't really want the screen to just be massively large and dropping down to width to a depth of 10,000. But we want the actual area available to be screen size. This is pretty much the equivalent of the area available, and I want that to be the equivalent of width, comma depth, like that. Anything else? What would be definitely important is to turn off any of the graphics and additional things that we can add to the screen. We want a bare bone simple screen. This needs to be non-capitals when I'm actually using the phrase false on Python. And one thing, I'll come to this later, but I'm going to define something called a canvas. And the canvas is going to be when I take that screen and I make it move. So I'll talk about this in more detail later, otherwise I'm going to slow down and cause confusion. I need to just show what that means later. So we have canvas equals screen.get canvas. The general construct of this is that it allows the screen itself to, not the screen that's in this area, it allows where your vision of the position where the turtle is to move. So you can see the moving turtle. But anyway, I'm doing exactly what I said I shouldn't do and try and describe it without just showing you. So let's create our ball. Our ball is equal to turtle dot turtle, and I want it to make it look like a ball, so let's make it a circle, something like that. A couple of things I'm going to do just to see, just so we can see some stuff. Let's get rid of all of this at the beginning. Yes, I understand. Get rid of this. We'll keep that, and we'll just let this run. And there you go. So there you go. We got our ball equals ball is turtle. Turtle. It's a circle. Let's make it a little bit more fancy. People like red balls, so let's say ball color and make it red. And also let's make the screen a bit more fancy. Let's say screen dot background color. We want that to be black. And therefore, when I click run, boom, that's what we've got. And this is about 300 by 300 by definition because I've done width. A couple of other things I want for my ball. I want my ball to look, at the moment the ball is looking to the right, so that's natural. I want my ball to look up, so then I can describe gravity as minus forward. That sounds a bit strange, but I'll just show you what I mean later. So what I'm going to do is I'm going to do something called set heading. Set heading pretty much defines, in fact, you can always read these things. Set heading, to angle, float, none. At the moment, that means there's nothing in here. Set the orientation of the turtle to an angle. So literally, it's telling you you're going to turn this turtle's head to the angle that you want it. I want it to look up, so I want it to look 90 degrees. So it's going to go from looking up there to looking up. So that's turtle set heading 90. And you won't see anything if I press this because it's a circle. But if I, for example, got rid of the circle in here and I clicked run, you can see that it turned its little head upwards relative to the right. And if I got rid of that 90 and just left it blank, you can see that it's facing to the right there. So let's just put set heading in 90 and make it our ball again, and we can continue. So all right, good. What else do we want? I don't really want the ball when it's moving to produce a little string, that little line that it leaves behind. I don't want it to look like a yo-yo, so I'm going to sort that out first. Let's put ball dot pen up, and that will stop it from leaving that line. So for example, if I put here, let's say ball dot forward minus 10, like that, it should fall a little bit. And let's make it a little bit more specific so you can see it. It's now falling a little bit. And notice that it's leaving a red line. That we have put pen up in here. Pen up allows for there to not be a line, but it's doing it in order, of course. It's making the ball, it's making it red, it's turning it 90 degrees, it's then dropping -50, and then it's lifting the pen up. So if I wanted to make this a little bit more clear that it's just a ball without the line, I can put it before it does its little movement, and there you go, it fell a little bit. So we don't need this. Let's get rid of this forward -50, but that's just to illustrate some stuff here. And before we move on, let's just go through this in a bit more detail, just in case. So for example, the first thing I would like to discuss is that, of course, we always begin with import turtle. So that's step one. We started off by describing the screen's width, and notice that the setup of the screen was width by width. So that is to say, the screen is 300 by 300. The actual area, so this part here could be described as the possible area of our screen where the ball can technically go. The area is the width times the depth. And I made it green on here because I didn't want to show it in here, but when I initiate this, it will say the screen's actual size will be width times depth, and that will be slightly different. That would be 300 by 10,000 because I want the ball to fall significantly. So that will be 300 by 10,000. And that means that this ball has the capacity to fall down an area of around 10,000. But I'm only going to do half of that today for reasons I'll discuss later. The main thing to also recognize is this is just to turn off any animation, any elaborateness, and this canvas equals the screen's got get canvas will be used later so that we can trace the ball as it falls down the screen. So that's what that structure is. Then I created my ball. This is the same construct as utilizing turtle. I said I want it to be a circle, and that's why, for example, we have our circle here, of course. I've made it red for the exact same reason. I think people at this point should be comfortable with that. And set heading 90 is at the beginning, everything is aiming to the right. And set heading 90, it means that it's going to turn its head left 90 degrees, which means that when I therefore I'm going to describe any of its movement, which I want it to be a falling ball, that's the goal of this project, it will have to describe it as a minus forward motion. So it'll be a negative forward motion. And that's what we're going to do. Pen up is simply so that it doesn't leave a line. We do not want a line. It won't look like a ball, pretty much. It'll look like a weird little yo-yo on a madness. So that is our basic construct of what we are up to at the moment. Next, let's add some information. I want to do something called gravity. Gravity is going to be, let's use physics constructs in here. Let's get madness, -10. No units whatsoever. So then this gravity is going to be -10. I'm going to define some code under the construct of move. I want you to move. And in move, let's put an if statement. We're going to say if the absolute value of ball's y coordinate, I need to be more specific. Ball dot, notice it's the same as ball dot color or ball dot set heading, ball dot pin up. Ball dot y coordinate will just find the y coordinate. And in fact, what I might do to just illustrate this so that you're not thinking what on earth randomness is that, I can start doing print. So if I put print and I put ball dot y coordinate like that, and I put run, you should see in the console 0, 0. But if I did some sneakiness and made my ball move forward the gravity amount, let's do that, make it move forward the gravity amount. Of course, I can't put that underneath there. It has to read gravity first. It'll be like, what is going on? So here we go. The ball moved, and my coordinate is now -10.0. So if I made it move, make gravity 10 times as strong, just crushing everyone on the planet, then we have the y coordinate is -100. So that's what that is. Let's put gravity back to normal. Let's stop this ball from moving, and let's get back to what our defining of some code here. So definition of move is going to, first of all, it's going to calculate if the absolute value of the ball's y coordinate, and you can see why I'm using absolute now. So that means that if it's -100 or -10 or -1000, it will give us the positive value of that. So that's something to be aware of. This means that no matter what the negative number is, it will give us the positive value. So what do I want it to write? I think I want something like, the absolute value of ball's coordinate needs to be less than the depth of the screen. And let's keep it divided by 2. Let's say half, because at the moment we're going to go to 10,000, and that's just a bit elaborate. Let's say divide by 2. And then what we're going to do is we're going to put some code in there. So in the beginning, it's a 0, 0. So if the absolute value of the ball's y coordinate, so that's 0, is less than 5,000, because this is depth divided by 2, right? So it's less than 5,000, then it's going to do some code. And of course, the absolute value is going to be less than 5,000 because the absolute value at the beginning is 0. It might move, but it's pretty much 0. So let's put some stuff in here. So just to prove this, actually, let's do some prints. Never do print with a capital. Let's do some prints. Let's say I want you to print the depth. That's just so you can see what I'm talking about. The depth divided by 2. And one more time, I'll also print. Let's put them in the if statement for now, because they're only there to aid in us understanding the weirdness that I'm doing up to this point. Let's put ball.y coordinate in there. And so look, you can see what I mean with this if statement. So, you know what? Let's bring this out so it's a little bit prettier. Get out. Bring this forth to here and bring this forth to here, and just get rid of this so that I can show you what I'm doing with these prints. So the first one, we've got 2 print ball y coordinates. So let's make that a little bit prettier. We're printing the ball.y coordinate, it's 0, and the depth divided by 2 is 5,000. And it's saying if the absolute value, let's actually put that in so you can see. No, I don't need to put absolute value in at the beginning, but if this number 0 is less than 5,000, it's going to do some stuff. And of course, it's less than 5,000. So just wanted to quickly show you what it is, what the numbers are that we're playing with. So let's do this. I want the ball to move forward by gravity, so minus 10. And clearly it's going to do it because the absolute value of the y coordinate is less than 5,000. Another thing I want to do, and this is where things get a little bit strange, is I'm going to make the canvas, don't forget we defined canvas up here. Canvas is the screen, where canvas was pretty much just the screen, and it's going to move with the ball. So canvas, the y view, right? The y view of that canvas, so the y coordinate of that canvas is going to do move to. We're going to move it with the ball, and I want it to move it a certain amount. So the y view of that canvas is going to move this. How much should we do it? Let's do depth divided by 2. So that's the equivalent of 5,000. Take away the y coordinate of the ball. That y coordinate of the ball can go to minus 5,000. So depth divided by 2 minus 5,000 is the equivalent of adding them together. So I'm saying I'm going to take 5,000 and I'm going to add from 0 to 5,000. So as the ball falls, this number gets larger. This depth divided by 2 take away ball.y coordinate gets larger. At the beginning, it will be 5,000 plus 0. And in the end, it will be 5,000 plus 10, 20, 30, 40, 50, 60, 70, all the way to 5,000. So it's going to go from 5,000 to 10,000. That's what that is. And if I take away, let's take away the width divided by 2, which is about 150, so about half the size of the screen. If I take that away, it means that it will never go to 10,000 because we already are 150 down the screen, so we need to take that into account. So this value in here is the equivalent of starting at 5,000 plus 0, and then it will go to 5,000 plus 5,000, so it will go all the way to that 10,000 mark, but it will take into account that it's already 150 down the line. So really, as the ball falls, this value will just keep increasing, maxing out at around 850. And then we want that to be a percentage, because there's a requirement for the canvas.y view move to for it to be a percentage. And so as a result, I'm going to make sure that this is the equivalent of depth divided by 2 minus ball.y coordinate minus width divided by 2 divided by depth. I'm going to divide by depth as the last part here, and then I will show you specifically in a moment exactly what that looks like. But it will start out as a smaller number and will go to a much larger number as a percentage. So when the ball hits the ground, it will reach nearly 100%. It can't do it because I'm already 150 down the page, but that's a basic description of what canvas.yview moved to. The maths is not important. I'll show you what these numbers mean in a moment. So if I do a print, if I ask to print this stuff in here so you can see what's going on, what I will do is I've produced move. So this is actually going to run this code in the definition. And when I click run, you'll see that it comes up with 0.486. So let's do a couple of things. Let's say the ball has moved forward by the amount of gravity. If I remove that, so the ball hasn't moved and it's just in its original starting position, and I click run, then you still have your 0.485 here. Now what I'm going to do then is I'm going to say, okay, let's make it move twice. So times 2. So it should have gone down by times 2. You got 0.487. If I say times 20, so it's times 20, the value becomes 0.505. If I say times 200, so it's minus 2,000 down the line, the ball will be moving. It is 0.685. If I get to 400, so it's minus 10 times 400, so it's close to that 5,000, 0.885. And if I just say I want this thing to move down 5,000, so let's say I just want it to move down minus 5,000, it's at 0.985. So all of this code in here, all of this equation, one other way to view it is it tells you the percentage or that the ball has moved down the screen, because at max we're allowing it to move at 5,000. We want this to happen to 5,000. So when it gets to when I've made it drop to 5,000, it's done 0.985 of the screen. If I drop it to exactly half of that, let's just put it back in its original position of 0, it will be a much smaller 0.485. And if I make it, say, let's do 3,000, so close to make sure this is minus 3,000, so it's dropping down the screen quite a bit. It's got to about 78% of the screen. If I do 4,000, it will get to about 87% of the screen. And finally, if I do 1,000, it will be much closer to that 0.5 value we got earlier. So what this code does is it tracks the movement of the ball and gives it to us as a percentage of the screen, wherein the lower it is, the closer it is to 100% of the screen, or the 100% position of the screen, and the higher it is up to this point is around 0.5. That's what that does. So I'm going to remove that for now and move on. Like I said, the maths of this is not as important, and the best way, in my humble opinion, to get used to that kind of code is to just play with it as much as you can. So let's move this back to gravity, so it's moving at minus 10 per cycle. And I've done the canvas is y view is going to move to the correct percentage of the screen depending on how the ball has fallen. That's what that pretty much means. And what I'm going to do in addition, I'm going to say screen.update. So we want to update the screen so it actually moves to the correct position. And we want screen to do this on timer so that every few seconds, or every millisecond, the on timer is going to move, is going to literally run this code, like run move, and it will happen so that in 1 millisecond it will check if it's within the correct range. It will make it move down gravity minus 10 points. It will move the screen in equivalent position, and then it will update the screen, and then it will cycle again. So that's what that means in a nutshell. So let's move on a little bit. Let's create a marker, because the problem we will have with this, another thing I want to do actually before I move on is get rid of the black, because we're going to make it so that there are some visible marks to see your falling ball. So the next thing I'm going to do is I'm going to do a marker. A marker is literally just going to be the equivalent of a turtle that is going to be invisible and state where it is in terms of X and Y. So I'm going to make a brand new turtle called marker. I'm going to make that marker hide because I don't want another turtle here. I just want something that's going to move along and state where it is, state a value. Marker, I don't want a line along my stuff, so let's do pen up. The marker is also going to be something that is going to tell us the y values. So let's set the x so that it's right in the middle of the screen. So let's say that this is 0, right in the dead center is 0. I don't want it to have the numbers right in the dead center because that's where my ball is going to fall. I would like it to be about minus, not minus 300, that would be the width. If I said minus width, it would do minus 300 because I've said the width is that, and that will send it off the screen because this is minus 150, so this will send it off the screen to minus 300. So what I do instead is, let's say we want the width to be minus 10, divide by 10. So it's, instead of 300, it's about 30. So it's minus 30. So the values of the y coordinates will be around there. And that's because I've moved the turtle to not be in the dead center with the ball, but to the left slightly. That's pretty much what that says. And then what we want to do is we want to make that ball fall, right? That marker. We want this marker to fall with the ball. So for y, we're going to use y here. We've done these kinds of loops in the past. There shouldn't be anything too elaborate for me to say for y in range. I'm going to need to print to show you what I'm doing here. But again, bear with me for a bit. Let me just show you, and then I can give more detail later. Depth divided by 2. So that's that minus 5,000. We want it to go from 5,000. Then we want it to drop to depth divided by 2 to the other end. So that's the minus 5,000 in steps of maybe 100. And one thing to be aware of regards to for loops is that division needs to be written like that. And then and never forget your colon. And then what do I want it to do? I want it to print the y value. Of course, I've said this before, we must make sure that is not capital, permission. There we are. My y value is also not a capital, so let's make it like that. And then in addition to that, we want the marker, this is the turtle, right? So this is our turtle. We want it to set y. Now set y as y, really. I'm pretty sure that's the right code. We'll check that later. And we want the marker to write. We want it to write the y value, and I want it to be aligned. Let's line it up right. Let's run it up. Right, like that. And again, play with these things when you have your own code, when you can change things. So what's going to happen is, I've made a turtle. I've made it hidden. I've made it not draw a line. I've set it slightly to the left of the center. I've then done a loop. And I put print y in here so you can see the values that are going to come up with this. And it's going to go in steps of 100 from 5,000 all the way to minus 5,000. And it's going to, the turtle is going to set its y, start off in the y position, and it is going to drop down. It's going to drop down and write the y value slightly to the right. That's what that means. And again, we'll discuss that in more detail later. But for now, did you see that motion? So I'll notice how it starts off at 5,000 because I start off on minus. This is because I'm printing y, right? It starts off on minus depth divided by 2, and the depth is 10,000. So it's going to be minus 5,000. It's going down in hundreds all the way up, all the way to 5,000. And if you look here, and what I'm going to do is I'm printing this, and this turtle is writing on the screen like a graffiti, like a hooligan. It's writing on the screen, and it's writing 4,900, blah 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 blah. Writing goes along the screen, slightly to the left. So for example, if I change this to, let's say, 1/3, it's going to be much further to the left. So we've got, see that, it's much further to the left because here is 0 and it's now minus 300 divided by 3. So it's minus 100 from the center of 0. Okay, so let's analyze this code one more time, just in terms of a couple of things, but particularly this if statement. So this if statement pretty much says that the depth of 5,000, so this will be minus 5,000. We can say this is the depth itself would actually just be 5,000. So it'd be 5,000 because it's 10,000 divided by 2. The absolute value of the ball's y coordinate at the beginning will be 0. But then with time, the ball's y coordinate will change just to -10, then -20, -50, -100, -1000, and it will keep going until it reaches -5000. That's in the end. So in the end, we can say that the ball will drop to -5000, but at the beginning, it will be a value of 0. So if we take the absolute value of that, let's say we say, okay, at the beginning it's 0 and then it goes to -5000. The absolute value of that means that it will start off with 0 and then it will go to 5000 because it is absolute. So that's the first thing to be aware of. Because it is absolute, it will take the 0 and then the 5000. So this if statement will run this code as long as the ball has not reached the bottom. That's another way of saying that. Because when the ball reaches the bottom, it will be at 5000, and therefore this will not be less than the 5000. When it reads that, it will simply make the ball move. So the ball will move down with gravity. Because do not forget the gravity value that we gave was -10. So the ball will keep dropping down -10 from the original position all the way down. And so it will start off at 0, and then it will go to -5000, and it will do this in steps of -10. And what will happen is that this screen here will be updated, and it will move. It will run the code move, and will move with the ball on a timer, and which is like every millisecond. And how does it do this? Well, the canvas itself will move its y coordinate dependent on the position of the ball. And we've been through this recently. This is pretty much the reason why it's divided by depth, because it gives you a percentage. It says that at the beginning, the value of the screen is around 0.5, and that by the time it reaches the bottom, the value of the screen is around 0.99 as a percentage. Now, this doesn't mean much to us. This is mainly just because of the way that this function reads the values that are put in here. But one thing to be aware of, and just to be mindful of this, that when you do canvas.yValue move to or .xView move to, then it needs to be given as a percentage of the whole thing. So therefore, you can argue that the screen is something that's the actual area is something that's like this. This is the actual area of the screen, and you can describe that at this point of the screen here. You could say that the screen is around 0.98 of its full length there, and here, because the screen's a little bit higher, it reads a value of around 0.5. And so every time that value changes, say it goes to 0.6, it will match around here. 0.7, it will match 0.8, 0.9, and then finally close to 0, close to 1. And so the screen itself, let's say the screen is like a yellow box. This yellow box here will, when it says 0.5, it will give you a view of this section. When it says 0.6, it will give you a view of this section. When it says 0.7, I don't want to spin it, it will give you a view of this section of the screen. 0.8, this section of the screen. 0.9, this section of the screen. And finally, when it reads 0.98, it will give you that bottom section of the screen. So the screen itself will travel down depending on the percentage that comes from this equation here. And we've already printed what that percentage is, so hopefully you get an idea. It's a little bit strange and a bit sus, but the main thing I would suggest to you is to play with the numbers yourself, and you'll finally figure out what I'm talking about, rather than this elaborate diagrams and mathematics. What else needs to be discussed? The next thing I think is fundamental is this idea of the marker. So the marker, you can see here there's a -4,800 in this diagram here. That is because I have another turtle. Here I have another turtle. My turtle is called marker, and it is invisible. It is not something you can see. So you're only ever going to get the numbers that the turtle spits out onto the page because it is invisible. It's not going to leave a line because I've got pen up. So there's no line here. Nice. Additionally, I've set where it is. I've set it slightly to the left by putting minus width divided by 3. I can make that divide by 10 and it will be a little bit closer. Just to be aware here, if I made that the marker set X and I left it at minus width, it would be at -300, so something around here. If I made it minus width divided by 2, it would be around 150, so around here. Because it's minus 50 divided by 3, it is around here. and that is why the values are popping out at that this x coordinate. If I just said that it was minus width divided by, let's say, 10, because the width is 300, then it will only be minus 30, so it'd probably be around here. So hopefully you can recognize that what I'm trying to suggest to you is that 0 is in the center, minus 300 is around here, and so minus 150 is around here. And because we have decided to do minus 300 divided by 3, which is around minus 100, it's giving the values in that position. And I think you get the drift of that. So that's what it is. It's just setting how far out from the center you want it to be. If I made it minus 1,000, it would be out here. But instead, it's just traveling down this point in time. And then I've produced a loop. We've got a lovely little loop here. And the loop, what is it looping through? Well, what it's doing is it's producing values in steps of 100. Don't forget that that last comma represents steps. In steps of 100, starting off, and this is division, that double slash here is division of 5,000, then it will go all the way to the equivalent value of minus 5,000 in steps of 100. And we've done a print screen, and we can always just print, whenever I do the code, it prints Y, so I will be able to show you this in a moment. And all the turtle is going to do, remember my turtle is called marker, that is just my turtle, it's an invisible turtle called marker. All the turtle is going to do is it's going to move according to the Y position, so move accordingly, and it's going to write what its Y position is, and which we allow, therefore that's what it's doing here. It is going to write its Y position as it falls with the ball. And then finally I run move, so move is being run, and then I make sure the screen does a nice little loop so that the screen consistently updates itself. So let's go back to the code and see what that looks like in real life. So here you can see width is 300, depth is 10,000. I've made my screen, I've set it at 300 by 300 at the beginning. The screen size is, the area itself is a lot larger. The area itself is all the way down to 10,000. I want no elaborate animation, and I want the screen to be able to travel. I've got a ball, it is a circle. Let's run this so you can see this. I've got a ball, there's a circle, it's a basic black circle. I could change its color if I wanted to. Let's say I wanted to make it ball dot color, and I say I want it to be red this time, the traditional red ball. You can see there's my red ball falling. It's falling with a value of gravity of minus 10. I don't need this elaborateness. With regards to the main code I've defined as move, and if the ball's Y coordinate is less than 5,000, it is going to keep falling. That's pretty much what that says. Move the canvas accordingly depending on the percentage of the screen that it moves down the ball. Update the screen, keep changing it, run this code move on a timer of per millisecond. I want another turtle running along the bottom that's going to mark out the Y coordinates. So it's going to write the Y coordinates, and it's going to do so. And then what you have is a falling ball that will stop. The if statement stops when the Y coordinate is also equivalent to that 5,000 point. And you could see here, I've printed, whatever I'm printing, I'm printing the Y values. So you can see it goes from minus 5,000 to 5,000. It's just a way for me to make sure that that turtle moves accordingly. But the main thing that we have here is a complete code that you can then play around with to get comfortable with these constructs. But that is the equivalent of having the screen follow a moving ball or moving object in Turtle. Thank you very much.